What if everything you know is moving but you can't feel a thing? What if the silence of the stars is a lie told by distance, and the calm of the sky is just a trick of perspective? Imagine standing on a carousel so vast, so smooth, that it feels like the earth itself isn't spinning beneath your feet. The constellations seem frozen, the moon glides like a ghost, and yet, beneath it all, you're hurtling through the cosmos at unimaginable speeds, orbiting, spiraling, falling through space. Stillness is not real. It's the most persistent illusion in the universe. Please like and subscribe, because this journey will change how you see our place in the universe. Prepare yourselves. We begin. We look up at the sky and see permanence, predictability, a kind of cosmic silence. The stars don't race by. They sit still, familiar, comforting. The Big Dipper returns night after night. Orion marches across winter skies like clockwork. The moon changes its face, but never its rhythm. The planets meander, sure, but they always come home. To the ancient mind, this was sacred. The heavens weren't just a mystery, they were a message, a great tapestry woven by divine hands. The sky was a ceiling, fixed, eternal, and we were the floor, the foundation, the center. And why not? The earth felt steady, solid beneath our feet. The skies rotated above us, not the other way around. Every sunset reaffirmed the idea. The sun goes away, and we remain. The illusion was so perfect, so seamless, that no one questioned it for thousands of years. Why would they? So we built entire systems of thought upon that foundation. From ancient China to Babylon, from Mayan astronomy to Greek geometry, the heavens were seen as moving in divine order and always around us. The sun, the moon, the stars, all were part of a celestial machine set in motion by gods or fate. Everything had its place, everything turned, and we were the still point. It wasn't ignorance that held this view in place. It was elegance, simplicity. It matched what the eyes could see, and it made sense of the seasons, eclipses, alignments. Calendars were carved from the heavens. Astrology flourished. Kings justified power by the stars. Farmers planted by the moon. Stillness was security. Stillness was truth. Until one day, it cracked. The tremor didn't come from an earthquake, it came from a thought. A Polish priest named Copernicus, hidden away in libraries and calculations, quietly asked a forbidden question. What if the earth moved? It was a small idea with seismic consequences. He imagined the sun, not earth, at the center, and suddenly, everything made more sense. The backwards loops of Mars, the changing brightness of Venus. The complex dance of the planets was no longer a cosmic riddle, it was a matter of perspective. But Copernicus was afraid. He waited decades to publish. The old system, the Earth-centered cosmos, was beloved, revered, and enforced. To challenge it wasn't just academic, it was heresy. Then came Galileo. He didn't invent the telescope, but he pointed it at the sky and saw something no human had ever seen clearly before. Moons circling Jupiter, a solar system within a solar system, a smaller cosmos orbiting something other than Earth. That was the second crack. Next came the third, and it was devastating. Johannes Kepler, working from mountains of planetary data, realized something terrifying to ancient logic. Planets don't move in perfect circles. They travel in ellipses, ovals, imperfect paths. The cosmos wasn't drawn with divine compasses. It was messier, sharper, stranger, but it obeyed laws we could describe, predict, understand. The universe was moving, and not just a little. We now know that Earth spins on its axis at about 1,670 kilometers per hour. That's fast enough to cover the entire length of the equator in a single day, but we don't feel it. There's no wind in your hair, no tug on your bones. The stillness persists. But that's only the first motion. We also orbit the sun at 107,000 kilometers per hour, a silent, invisible fall around our star. One full revolution every year, a journey we never feel. We are constantly free-falling, and yet we call it stability. But it doesn't stop there. Our solar system, spinning and orbiting in beautiful nested harmony, is itself flying through the Milky Way galaxy at around 828,000 kilometers per hour, faster than any spacecraft we've ever built. Still, the stars look still, and even the galaxy moves. It drifts through intergalactic space, drawn by forces we didn't even know existed a century ago, toward clusters, superclusters, towards something we only now begin to glimpse: the great attractor, a gravitational ghost pulling galaxies like leaves in a current. Yet, through it all, we feel nothing, nor rumble, nor lurch, nor drag. The illusion of stillness remains until you know the truth. We are inside a hurricane we can't feel, flying through space we can't see, carried by forces we can't resist. The calm is not the absence of motion, it is the balance of it. Everything is moving, and we are moving with it. What feels like stillness is simply synchronization. What happens when the wrong idea is beautiful enough to last 1,000 years? What if a model of reality, so elegant, so symmetrical, so reassuring, becomes more powerful than truth itself? What if the sky above you was never designed to reflect reality, but to comfort your soul? For the ancient world, this wasn't a question. It was scripture. The cosmos was ordered, divine, and precise. Not chaotic, not empty, not spinning into oblivion. The stars followed rules, sacred circles in sacred silence, and at the center of it all, unmoving, unchanging, sat Earth. Not because we were arrogant, but because we were human. Look around you. The world feels still. The heavens feel far away. The sun rises, crosses, and falls. The moon waxes and wanes. The stars return in their perfect arrangements. No matter what language you spoke, or gods you believed in, this was undeniable. Everything moved around us. This belief, this picture wasn't just myth. It was machinery, a finely tuned system with us at its heart. And no one described it better than Claudius Ptolemy. He lived in Alexandria in the 2nd century CE, under the rule of Roman Egypt. A scholar, mathematician, astronomer, and cartographer, Ptolemy didn't invent the idea of a geocentric universe, but he turned it into a masterpiece. Drawing from Babylonian star records, Egyptian timekeeping, and Greek geometry, Ptolemy wrote a monumental book, the Almagest, the greatest work. And for over 1,000 years, it would live up to its name. In Ptolemy's universe, Earth was the throne, perfectly still, perfectly central. Around it spun everything: the moon, Mercury, Venus, the sun, Mars, Jupiter, Saturn, each in its own perfect crystal sphere, and beyond them all, the stars, fixed to the outermost shell like diamonds on a turning dome. This wasn't science versus religion, this was science. For its time, Ptolemy's system worked. It explained the sky, predicted eclipses, tracked the movements of the planets with surprising accuracy, all using geometry and observation. It was practical, logical, even beautiful. But then came the problem. Planets don't behave, especially Mars. Over months, ancient observers noticed that Mars would slow down, stop, move backward for a while, then resume its forward path. This strange retrograde motion shattered the idea of simple, perfect circles around Earth. It made no sense. So Ptolemy introduced a fix, not a revolution, a workaround. He invented epicycles, small circles on which a planet moved while the center of that circle orbited Earth. Picture a dancer spinning in place on a merry-go-round. The planet wasn't just going in a circle, it was looping on a loop, and when that still didn't line up with the data, he added more corrections. The deferent, the large circular orbit, and the equanta mysterious, off-center point from which a planet's motion appeared uniform. It was elaborate, baroque, a patchwork of adjustments, but somehow it worked. It wasn't physics, it was choreography, and for over 1,000 years, no one dared break the rhythm. This wasn't just a scientific model, it was cosmic architecture. Ptolemy's system wasn't just about planet. It shaped calendars, informed agriculture, structured religious holidays, It was the foundation of astrology, timekeeping, even philosophy. It gave kings their omens and empires their legitimacy. Because if Earth was the center, so were we. You weren't just a speck in the void. You were at the heart of the universe, held in a divine geometry crafted by celestial intelligence. This was more than science. It was existential safety. But here's the secret the cosmos never says aloud. Even the most beautiful lie must eventually collapse. Because the universe doesn't care about your symmetry. It doesn't revolve around your comfort. And it certainly doesn't orbit Earth. As instruments improved and measurements became sharper, the seams began to show. No matter how many epicycles you added, no matter how finely tuned the equants became, the system groaned under its own weight. It took a long time for anyone to say it out loud, but eventually, one man did, and everything would begin to change. Sometimes the greatest revolutions begin not with a battle cry, but with hesitation. No thunder, no riots, just a man alone in a library quietly rewriting the heavens. His name was Nicolaus Copernicus. He was not a warrior, not a prophet, not even a professional scientist. He was a priest, and yet, in the stillness of cathedral halls and candlelit observatories, he conceived an idea so dangerous it would unravel the cosmos, not with rage, but with logic. He looked at the 1,000-year-old cosmic machine Ptolemy's grand orrery and saw not divinity but clutter, loops on loops, epicycles orbiting deferents, orbiting equants. It worked, yes, but it no longer breathed truth. Something was wrong, so Copernicus did what few dared to do. He stepped outside the painting. He imagined the sun, not the earth, as the anchor of motion, and in that single act of imagination, the entire clockwork universe spun on its head. Suddenly, the heavens didn't revolve around us. We revolved around them. It was elegant, liberating, and terrifying. Because if Earth moved, then everything we thought was still the stars, the sun, the heavens was moving in relation to us. The illusion shattered. The pedestal cracked. But Copernicus didn't shout. He whispered. He hesitated. For decades, he kept his theory mostly to himself, scribbled in notebooks, shared only with close confidants. He knew the world wasn't ready. The church, the scholars, the empires, all of them built on a foundation that placed Earth at the center of divine creation. To pull that foundation away was to crack not just astronomy, but theology, politics, and identity itself. Still, he kept writing. His book De Revolutionibus Orbium Coelestium, on the revolutions of the celestial spheres, was a quiet grenade. It wasn't even published until 1543, the year he died. Legend says a copy was placed in his hands on his deathbed. He blinked and then closed his eyes forever. But the fuse had been lit, and the fire could no longer be stopped. Copernicus proposed 3 astonishing motions for Earth. Daily rotation. Earth spins once every 24 hours on its axis. That's what makes the stars appear to rise and set. It wasn't the heavens turning, it was us. Annual revolution. Earth orbits the sun once per year. That explained the seasons, the backward paths of planets, the shifting constellations. Axial wobble, a slow procession, tracing a circle in the sky over thousands of years. The subtle drift of the poles, the long dance of celestial calendars. These weren't guesses. Copernicus backed his claims with geometry, trigonometry, and decades of observations. He calculated planetary distances based on orbital speeds. The closer a planet was to the sun, the faster it appeared to move. That single rule rearranged the solar system. But still, it didn't convince everyone, because Copernicus made one crucial mistake. He clung to the old faith in circles. Like Ptolemy, he still believed the heavens must move in perfect, divine curves. So while his model was conceptually simpler, it wasn't much more accurate. In some cases, it predicted planetary positions worse than the old system. The truth was clear, but the math still resisted. The world needed something more. Not just a shift in philosophy, a shift in vision. And that vision would come not from a theorist, but from a lens. What happens when the sky finally looks back? What happens when the divine canvas of stars, untouchable, untarnished, is suddenly scarred, cratered, and flawed? When the heavens, long praised as perfect, reveal themselves to be made of the same broken stuff as Earth? That moment came not in a cathedral, but in a workshop. It began with a toy, a novelty, a few pieces of curved glass arranged in a brass tube. Not divine revelation, not a philosopher's dream, just optics practical, humble. And then Galileo Galilei pointed it skyward, and the sky shattered. It was the early 1600 seconds, and Galileo didn't invent the telescope. Dutch spectacle makers were already tinkering with the idea, using lenses to bring distant ships into view. But Galileo had a gift, not just curiosity, but courage. He refined the design, sharpened the magnification, and then he turned it not toward the sea, but toward the stars. And suddenly, for the first time in human history, the universe wasn't imagined, it was seen. He looked at the moon, the very symbol of divine serenity. But it wasn't smooth. It wasn't flawless. It had mountains, craters, shadows. It looked like Earth. That alone was heresy. The heavens were supposed to be made of some special substance, a perfect, incorruptible fifth element. But here was rock, scarred, jagged, mortal. Next, he looked at Jupiter, and what he saw changed everything. 4 tiny points of light dancing around the planet. He watched them night after night, tracking their motion. They moved, orbited, disappeared, and returned. They weren't stars, they were moons. Moons that didn't orbit Earth. That was impossible in the old system. According to Ptolemy's model, everything circled us. The idea that Jupiter, a wandering star, had its own companions, it cracked the central pillar of the geocentric faith. The Earth wasn't unique. The universe was plural. And then, Venus. Galileo turned his telescope to the morning star, that brilliant beacon in the dawn sky, and what he saw sealed Copernicus's fate. Phases. Venus went through phases, just like the moon crescent, half, full. But in Ptolemy's universe, this was impossible. Venus was supposed to orbit Earth closer than the Sunday. It should always appear as a crescent. But if it orbited the sun, then sometimes it would be behind it, fully illuminated, and other times in front, just a sliver of light. And that's exactly what Galileo saw. That tiny glowing dot in the sky, silent for millennia, whispered a secret. The sun is at the center. The telescope had done something Copernicus never could. It gave the revolution eyes. What had once been a theory, a quiet, whispered heresy, became visible, measurable, undeniable. The heavens were no longer holy paintings. They were terrain. They had depth, flaws, motion, story, and yet, not everyone rejoiced. Galileo's discovery sparked wonder and fury. The church resisted. Scholars scoffed. His own students betrayed him, because Galileo didn't just observe. He spoke, he wrote, he challenged. He didn't whisper like Copernicus. He shouted, and the world wasn't ready. In 1633, he was put on trial for heresy, forced to recant, silenced, sentenced to house arrest. Legend says, after being forced to deny Earth's motion, he muttered under his breath, "Eppur si muove," and yet, it moves. The revolution had begun. Galileo cracked the ceiling. He gave us sight, but the universe was still waiting for someone to give it shape. The clockwork of the cosmos, the precise geometry of its motions, still needed to be decoded, and for that we would need a man obsessed with perfection, who would learn to let go of it. What if the universe isn't perfect, but it's precise? What if the sky doesn't dance in circles because it's divine, but in ellipses because it's honest? What if the most sacred shape in philosophy, the circle, had to be sacrificed to uncover the real shape of the cosmos? The man who made that sacrifice was not born to break beauty. He was born chasing it. Johannes Kepler believed in harmony. He saw the universe as music written in numbers, the music of the spheres. He wanted to read the mind of God in planetary motion. He was devout, meticulous, and unrelenting, and he would suffer to uncover a truth no one wanted. Kepler didn't start with a telescope. He started with a master, Tycho Brahe, the last great naked-eye astronomer, was a Danish nobleman who built observatories like cathedrals. He tracked the stars with instruments the size of houses, measuring the planets with such accuracy that even today they astonish. But Brahe had a problem. He didn't trust Copernicus. He couldn't believe Earth moved. So he built a hybrid model. Planets orbited the Sun, but the Sun orbited Earth, a cosmic compromise. Then he hired Kepler. Kepler was poor, devout, and obsessive. Brahe was wealthy, proud, and secretive. They clashed constantly. But when Brahe died, he left his treasure trove of planetary data to Kepler. And Kepler, driven by a need to see cosmic order, buried himself in it. He chose a battleground, Mars. Mars is a troublemaker. Its motion in the sky is maddening. Sometimes it speeds up, sometimes it slows down. Sometimes it moves backward, tracing strange loops against the stars. For centuries, astronomers forced Mars into circular orbits using epicycles, deferents, and equants. Kepler tried the same, over and over. He was convinced Mars must move in circles. Circles were perfect, divine, sacred. But the data refused to agree. The math never aligned. It didn't matter how he tweaked the geometry. There was always an error, a tiny mismatch, a stubborn defiance of celestial logic. Most astronomers would have given up, or forced the data to fit the theory. But Kepler did something radical. He surrendered it. He let Mars speak, and what it said changed everything. Kepler discovered that planets do not move in circles. They move in ellipses stretched, oval-like paths with the Sun at one focus. This was heresy to geometry, a betrayal of divine symmetry. But it worked. It fit the data. For the first time, the motion of Mars could be predicted precisely not as a compromise, but as reality. And from that epiphany emerged Kepler's first law. All planets orbit the Sun in ellipses, with the Sun at one focus. Suddenly, the sky wasn't choreographed in flawless curves. It was wound in gravitational tension, stretched by invisible rules. But Kepler wasn't done. He noticed something else, something subtle. As planets approached the Sun in their elliptical orbits, they sped up. As they moved away, they slowed down. Not randomly, but rhythmically, like a skater pulling in their arms to spin faster. This gave birth to Kepler's second law, a line joining a planet, and the Sun sweeps out equal areas in equal times. That meant a planet didn't move at a constant speed, but it moved with constant rate, a kind of cosmic heartbeat. Time and space, locked together in a flowing rhythm. Then came the final revelation. Kepler discovered that the time a planet takes to orbit the Sun, its period is related to its distance. The farther out a planet is, the slower it moves. But not just slower, predictably slower. The square of its period is proportional to the cube of its average distance. Kepler's third law, Pi parado, e cubo. This was the thread that stitched the solar system together, a unifying code, a whisper of order in the seeming chaos. Together, Kepler's three laws didn't just describe planetary motion, they transformed it into music. Not the mystical harmony he'd hoped for, but a deeper harmony, a real one written not in divine circles, but in elliptical truth. He had gone searching for God's geometry and found nature's mathematics instead. And yet, as monumental as these laws were, they still asked a question. Why? Why did the planets move this way? Why did ellipses happen? Why did motion accelerate and slow in such graceful curves? Kepler could see the pattern, but he didn't yet know the force behind it. To find that, the universe would need one more mind, someone who could see an apple fall and understand that it wasn't just the Earth pulling on fruit, it was the same force holding the moon in orbit. What if the same force that pulls an apple to the ground keeps the moon from falling out of the sky? What if every step you take, every drop of rain, every orbit of every planet is tied together by one simple rule, invisible, silent, and universal? For centuries, the sky and the Earth were treated as separate realms. Down here, weight, motion, friction. Up there, harmony, perfection, the music of the spheres. They were governed by different laws, or so we thought. Then came Isaac Newton, and in a single breath of genius, He tore down that ancient wall. He was quiet, withdrawn, not a fiery rebel like Galileo or a tortured mystic like Kepler. Newton preferred solitude, a mind that turned inward like a spiral galaxy, always folding in on itself. The story goes that one day, an apple fell, not in a storm, not in a vision, just a simple fall from a tree. But Newton didn't just see an apple. He saw a question: why down? And more importantly, why always down? What was this invisible tether between Earth and everything it touched? What compelled things to fall? And then he asked the bigger question: if the apple falls toward Earth, what keeps the moon from doing the same? That question changed the world, because Newton realized it does fall. The moon is falling. It's always falling, but it's also moving sideways fast enough to keep missing the Earth. That's what an orbit is, a fall that never lands. That was the key. What keeps the moon in orbit, what holds the planets around the sun, what keeps the tides surging and the stars circling, it's all the same thing: gravity. Newton didn't just name it, he defined it. He described gravity as a universal force between two masses. Everything pulls on everything, no exceptions. His formula was simple, yet profound. F equals G times M1 times M2 divided by R squared, where F is the gravitational force, M1 and M2 are the masses, R is the distance between them, and G is the gravitational constant, the hidden heartbeat of attraction. That single equation unified heaven and earth. It explained why Mercury races around the sun and why you fall when you trip, why the tides breathe in rhythm with the moon, why the solar system doesn't fly apart like scattered embers. It even gave Kepler's laws their reason. Why ellipses? Because of how gravity weakens with distance. The closer a planet is to the sun, the stronger the pull and the faster it must move. The farther away, the weaker the pull and the slower it drifts. Kepler saw the pattern. Newton gave it teeth. With Newton's law, we could finally predict motion, not just describe it. We could send objects into the sky and know where they'd be a year later, a century later, 1,000. The solar system wasn't just a mystery anymore. It was a machine, clockwork elegance driven by gravity's pull. And yet, what Newton revealed was far stranger than anyone expected, because motion is everywhere. Earth orbits the sun at 107,000 kilometers per hour. The sun itself is not still. It orbits the center of the Milky Way at 828,000 kilometers per hour. Even our galaxy moves pulled by forces across intergalactic space. We are part of a vast web of falling objects, each in free fall towards something bigger. But we don't feel it. We don't see the ropes. Gravity is silent, but it never sleeps. Here's the paradox. The same force that makes your feet press into the ground is the force that holds galaxies together. The mundane is cosmic. The cosmic is mundane. You are bound to the Earth, and the Earth is bound to the sun, and the sun is bound to the galaxy, and the galaxy is caught in a gravitational tide that stretches across millions of light years. Every mass in the universe is reaching for every other. Everything is touching everything invisibly. Gravity is the great unifier. And yet, even Newton could not explain what it was. He could measure it, predict it, use it. But when asked what gravity actually is, he replied, "Hypotheses non fingo. I feign no hypotheses." He didn't know. He had discovered the thread, but not the hand that pulled it. What if the sun, our anchor, is adrift? What if the one thing we believed, everything revolved around the giver of light, warmth, and time, is itself caught in a cosmic current, drifting silently through the dark? After Newton, we understood orbits. We knew the Earth circled the Sunday. We thought we had found our new center, but the universe has no center, only motion. And one man, half musician, half astronomer, would be the first to prove that the sun itself is not still. His name was William Herschel. He was born in 1738 inches, Hanover, Germany, a composer by trade. He played music in cathedrals, wrote symphonies, and conducted orchestras. But in his spare time, he built telescopes, grinding mirrors by hand, polishing glass with the same rhythm he once used to score violins. Then he turned those instruments skyward, not just to gaze, but to count. Herschel wasn't just looking for beauty, he was looking for structure. If stars were scattered across the sky, he wondered, are they random, or is there a pattern? Night after night, he counted. In narrow slices of the sky, only a few degrees wide, he recorded the number of visible stars. Over years, the pattern emerged. There were directions in the sky with far more stars than others, and that dense band, the Milky Way, it wasn't just a poetic smear of starlight, it was a clue. Herschel realized we were inside something, not outside looking in, but within. So, he sketched a map, a shape. It looked like a disk stretched and flattened, like a grindstone with the sun somewhere near the middle. For the first time in human history, someone had guessed the shape of our galaxy, not through theory, not through myth, but through data, through counting. Today, we know his model was wrong in the details. He didn't account for interstellar dust, the clouds of particles that obscure distant stars. That made his estimate of the galaxy's size far too small. And the sun, we now know, is not at the center. But Herschel's vision was revolutionary. He had proven the stars weren't infinite, scattered in a celestial wallpaper. They belonged to a structure, a system, a galaxy, and we were inside it. Then came the next question. If the galaxy has shape, does it also have motion? And if we have a location in that structure, does that mean we also have a trajectory? The old feeling that we were still began to dissolve completely. The Earth spins, the Earth orbits, the sun shines. But what is the sun doing? We once thought it was still the center of all motion, but we were wrong. The sun is moving at 828,000 kilometers per hour, pulled by the gravitational tide of the Milky Way. It's orbiting the galactic center, a point buried in the dark heart of our galaxy, completing one full revolution every 225 million years. One galactic year. Since the sun was born, it has only made about 20 trips around the center of the galaxy. We, our species, are barely half a second on that clock. And the Earth? The planets? We're riding with it, orbiting the sun as the sun orbits the galaxy, a nested spiral of motion. We are not standing still. We are leaves in a cosmic river. Herschel's star counts told us we belong to something larger. But they also hinted at something more profound. Motion leaves patterns. Motion leaves structure. The galaxy wasn't just a shape, it was a flow. And that meant we weren't just in a place. We were on a journey. So where are we going? Where is the sun headed? That's what astronomers began to ask. And with better telescopes, better math, and new eyes in the sky, we would soon discover the sun has a direction. It's falling through space toward a point in the constellation Hercules, a motion now known as the solar apex. But why? Why is everything moving? And what lies at the center of that spiral? What if everything we see, every star, every sun, every orbit is dancing around a darkness we cannot see? We used to believe Earth was the center. Then we gave that role to the Sunday. But as we chased motion further past planets, past stars, we reached a truth that shattered the concept of center altogether. The Milky Way is not a wheel. It is not a machine. It is a storm, and at its core lies something massive, invisible, and beyond comprehension, a gravitational anchor that pulls without light, holds without form, and binds the galaxy with silent strength. We call it Sagittarius A, but long before we named it, we felt its pull. We knew the sun was moving orbiting the galaxy, but that motion begged a question. What is it orbiting? The center of the Milky Way was buried behind veils of dust and gas impassable to optical telescopes. For centuries, it was invisible, a blind spot in the sky, a direction, but no destination. Until we changed how we looked, astronomers turned to radio waves, longer wavelengths that could pierce through the fog of interstellar dust. In the 20th century, we began mapping hydrogen, the most abundant element in the universe, using its faint, natural radio signal at 21 centimeters. This changed everything. Suddenly, we could see through the obscuring dust like shining sonar through deep water. And deep in the direction of the Sagittarius constellation, something strange appeared. It was not a light, not a glow, but a motion. Stars were whipping around something incredibly fast, especially near the center, objects orbiting at thousands of kilometers per second, velocities so extreme that only an enormous mass could be holding them in place. But that mass didn't shine. It didn't emit light. It didn't reflect anything. It was invisible. So, we began ruling things out. It wasn't a star. No single star could hold that much mass. It wasn't a cluster. It was too compact. It wasn't a gas cloud. Gas doesn't hold orbiting stars. All the math pointed to one conclusion: a mass 4 million times that of the Sun, compressed into a space smaller than the orbit of Mercury. Only one thing in physics fits those numbers: a supermassive black hole. We named it Sagittarius A, times the bright radio source that marks its location. It doesn't glow in visible light. It doesn't roar like science fiction. It whispers in radio waves and pulls everything. Stars orbit it in wild, looping paths. Gas clouds spiral into it, shredded by tidal forces. Time slows near its edge. Light bends, but despite its monstrous gravity, it is eerily still. It does not move. It waits. And we, the Sun, the Earth, every star we see orbit it, once every 225 million years. We are infalling, held on a leash of light-speed velocity, bound to a center that devours even the concept of place. We were never the center. We were never still. We were always falling. And yet even this is not the end of motion, because while we orbit Sagittarius A, it too is moving. The Milky Way is not fixed in place. It is twisting, warping, wobbling. Its spiral arms, including the one we ride, the Orion spur, ripple like waves. Gas clouds shear under gravitational strain. Star clusters dance in chaotic syncopation. The galaxy breathes. It is alive with motion, not static, but seething. Still, there's a deeper question. How did Sagittarius A times get there? How does a black hole millions of times heavier than our Sun form? We don't know. Not entirely. Some believe they began as smaller black holes, feeding, merging, growing over billions of years. Others suspect they formed in the chaos of the early universe, direct collapses of primordial clouds. But what matters more is this: every major galaxy we've studied has one. At the heart of spiral galaxies, elliptical galaxies, even dwarf galaxies, a supermassive black hole, the hidden anchor of structure itself. They are not accidents, they are architects. And so the story has changed again. Once we thought Earth was the still point, then the Sunday, then the galaxy. But now we know the truth. There is no still point, there is only orbit. And what lies at the center of the orbit is darkness. What if the greatest impact in our galaxy's history has already begun? Right now, as you breathe, as you blink, as you go about your ordinary day, the Milky Way is racing through space towards something vast, silent, and unstoppable. We've spent centuries watching the stars move, but in the 20th century, we realized something far more profound. We're not just watching the sky change, we are moving through it, and up ahead, something is coming. Her name is Andromeda, the largest spiral galaxy in our celestial neighborhood, a glowing swirl of stars, twice the size of the Milky Way, hanging 2.5 million light-years away and closing in. When scientists first measured her light, they were expecting redshift, the stretching of light caused by galaxies moving away due to the expansion of the universe. But Andromeda was different. She was blue-shifted, meaning she's moving toward us. Fast, over 400,000 kilometers per hour, and that's not counting our own velocity. The two largest galaxies in the local group are not drifting apart. They are locked in a gravitational embrace. We are on a collision course, but this isn't a Hollywood explosion. This is something bigger, slower, stranger. Galaxies are not solid objects. They are mostly empty space. Stars, though massive, are separated by light-years oceans of distance between them. So when two galaxies collide, they don't smash like billiard balls. They pass through one another, like ghosts, like waves. Still, the consequences are dramatic. Tidal forces stretch and warp the spirals. Streams of stars are flung outward, entire systems ejected into the void. Black holes begin to spiral toward one another, and the delicate balance of star systems, including our own, is rewritten. But here's what might surprise you. This galactic collision has already begun. Not the physical impact, but the gravitational one. The mutual pull is accelerating. In about 4 billion years, the galaxies will overlap. Tails of stars will stream into intergalactic space like cosmic ribbons. Spirals will unwind. New stars will be born in chaotic bursts. And eventually, over 1 billion years or so, the Milky Way and Andromeda will merge into a single, larger galaxy. Astronomers already have a name for it, Milky Way. It won't look like a spiral anymore. It will be rounder, puffier, a glowing elliptical ball of stars and dust. Our sun, if it survives, will likely be thrown into a new orbit, not where it is now, not inside a tidy spiral arm, but somewhere in the outer reaches of this galactic remnant, spinning in a new rhythm we cannot yet imagine. Still, we will not collide with Andromeda's Sunday. We will not see her cities, because the galaxies are too vast and the stars too far apart. The drama is not one of impact, it is of orchestration. But this dance, this slow 5 billion year ballet, is not unique. Galaxies merge all the time. It's how the universe grows. Cosmic structure is built not by stillness, but by collision. It's gravity's sculpting tool, creation by confrontation. Even now, we can look into deep space and see frozen moments of these galactic entanglements, twisted arms, doubled cores, stretched trails of stars, snapshots of galaxies mid-embrace. And we are next. But Andromeda isn't the only force tugging on us, because we don't exist in isolation. Our galaxy belongs to a group around 80 galaxies, including the large and small Magellanic Clouds, and dozens of others that swirl around us like bees. This group, in turn, belongs to a cluster, and the cluster to a supercluster, and that supercluster is also in motion. Gravity is not local, it is layered, and the Milky Way is falling towards something even bigger. But before we go that far, let us linger here, in this moment between galaxies, because there's something haunting in knowing that your home is on a path of cosmic collision. And yet, there's also something beautiful. The stars don't fear the end of the spiral. They don't resist. They merge. They birth new light. They become something else. So perhaps this is not a tragedy, but a transformation. A reminder that in the universe, nothing is truly still and nothing stays the same. What if you're not just orbiting a star, not just riding a galaxy, but falling into something you can't even see? The sun is not still, the Milky Way is not still, and even the collision with Andromeda is not the final destination, because when we zoom out, farther than any telescope used to dream, we find that everything is moving. And we're not moving randomly. We're moving with purpose, with direction. We're being pulled. But toward what? Our galaxy, along with hundreds of others, forms a community, a loosely bound neighborhood called the local group. Within it, galaxies orbit each other, merge, collide, and drift. But when we trace the motion of the entire group, when we stop asking where we are, and instead ask where we're going, the story becomes far stranger. Because the local group isn't just floating in space, it's falling through it. We are moving towards something massive, something mysterious, something pulling on everything around us. It's called the Virgo cluster, a swarm of over 1,000 galaxies roughly 65 million light-years away, and our entire local group is racing toward it at 600 kilometers per second. But even that is just a way station, because Virgo, too, is falling. All galaxies, all clusters, all matter, they don't just sit still in the universe. They follow the curves of gravity carved into the fabric of space-time. They flow, and scientists began to realize that these flows weren't chaotic. They formed patterns, coherent streams of galaxies, all racing in the same direction, like leaves floating toward a distant drain. So astronomers created cosmic maps, not of where galaxies were, but how they moved. That's when things got strange. because the galaxies were not flowing toward Virgo alone. They were all being drawn toward a hidden point, a region of sky that telescopes could barely see. They called it the Great Attractor, not because they knew what it was, but because they could feel it. Everything, the Milky Way, Andromeda, the Virgo cluster, was accelerating in its direction. It wasn't a guess. It was baked into the data, the peculiar velocity of galaxies, motion not explained by expansion alone, but by gravity. There was something massive out there, something that didn't glow, something obscured by the dust and stars of the Milky Way itself, hidden in a region called the zone of avoidance. But the math was undeniable. We were being pulled. Eventually, astronomers pierced the veil, using X-ray telescopes and infrared surveys, and what they found behind the curtain was staggering. A concentration of galaxy clusters, not just one, but many forming a dense gravitational knot, one of the largest structures in the known universe, the Shapley supercluster. This was no single object. It was a cosmic convergence, tens of thousands of galaxies, weighing more than 100 million billion suns, pulling on the surrounding universe, like a drain in deep space. And our galaxy, our home, is falling toward it. But here's the twist. We're not being pulled in a straight line, because gravity doesn't just pull, it bends. Imagine floating in a river. On one side, there's a waterfall. On the other, an open, empty plain. You're not being pushed by the plain, but because there's no resistance there, the waterfall wins. You drift. This is what astronomers discovered. Opposite the Great Attractor, they found something else, or rather, nothing. An immense region of emptiness with very little mass. They called it the dipole repeller, not because it pushes, but because it doesn't hold you back. The result? A gravitational current. We are flowing away from emptiness and toward mass, falling through a cosmic river, carved by contrast, mass and void, pull and release. This flow is not a metaphor. It is motion. We can measure it. 600 kilometers per second toward the Great Attractor. Thousands of galaxies falling with us. This is not a local event. This is not about stars. It's about structure on the grandest scale. We are not just part of a galaxy. We are part of a stream, a river of light and mass flowing across a cosmic web. And here's what's truly haunting. This flow never ends. Because when we map the universe on this scale, the largest scale, we see that galaxies don't just cluster. They arrange themselves into filaments, woven into a vast, frothy network, the cosmic web. Superclusters, walls, voids, threads of matter and galaxies stretching across billions of light years. And even these titanic structures are not still. They shift, they warp, they fall. The universe is not static. It is a cascade of falling things, a ballet of collapse and expansion, guided by gravity, veiled by darkness. So where are we going? We don't know. Not completely, because even now, with all our maps and measurements, the destination of this cosmic river remains unclear. Perhaps it leads to deeper structure. Perhaps it's shaped by forces we have yet to understand. But what is certain is that we are not standing still. We never were. We are falling, together, towards something vast, ancient, and unseen. What if everything you've ever seen is just a shadow on the surface of a deeper, invisible reality? The stars, the galaxies, the gas clouds, the nebulae, everything we've mapped with telescopes, everything we've watched shimmer in the night sky. It all adds up to almost nothing. All of it, the entire visible universe, is only about 5% of what's actually there. Let that sink in. 95% of reality is missing from view, and yet, it is this invisible bulk that shapes the cosmos. We begin with dark matter, the quiet architect. It does not glow. It does not emit heat. It does not reflect light. And yet, it holds galaxies together. Without dark matter, the Milky Way would tear itself apart. Without dark matter, stars would fly out of their spirals like sparks from a pinwheel. We only discovered it because of what it does, not what it island. Astronomer Vera Rubin was one of the first to notice something was wrong. As she studied how galaxies rotated, she expected to find that stars on the outskirts moved more slowly than those near the center. But they didn't. They were moving too fast. Far too fast for visible gravity to hold them in. It was as if there was more mass than we could see, a hidden scaffolding holding the galaxy together. Today, we know this scaffolding extends across the universe. Dark matter weaves an invisible web that galaxies cling to. It clusters. It merges. It flows with gravity, shaping the cosmic web we saw before: filaments, voids, and nodes of light. We can't see the dark matter itself, but we can trace its fingerprints through the motion of galaxies, through gravitational lensing, where dark matter bends light like a ghost pulling on a mirror, and through its role in the birth of cosmic structure after the Big Bang. And yet, we don't know what it island. Not completely. We've ruled out most ordinary matter: protons, neutrons, electrons. It's not just faint gas or dust. It's something else. Maybe exotic particles. Maybe something more profound. A new force, a new field, a missing piece in the puzzle of existence. But dark matter is only half the mystery. The other half is even stranger, because while dark matter pulls things together, dark energy pushes them apart. It all started with a question: how fast is the universe expanding? Scientists expected the expansion to slow down over time, the way a ball thrown upward slows as gravity pulls it back. But in 1998, two teams of astronomers discovered something shocking. The universe wasn't just expanding, it was accelerating, as if some invisible force was stretching space itself faster and faster with every passing second. And this force wasn't a local anomaly, it was everywhere. It wasn't just acting on matter, it was acting on space-time. So what is it? We call it dark energy, not because we understand it, but because we don't. It fills the universe. It makes up nearly 70% of the total energy content of the cosmos. And yet, we have no idea what it island. Some say it's a property of space itself, a cosmological constant, as Einstein once proposed and later abandoned. Others believe it may be a dynamic field, a new kind of energy, woven into the vacuum of the universe. Whatever it is, it's winning, because over cosmic time, as galaxies drift farther apart, matter becomes more dilute, but dark energy stays the same. The more space there is, the more dark energy fills it. And the more dark energy there is, the faster the universe expands. It's a feedback loop, an engine of expansion. And this changes everything, because it means the universe has a fate. If dark energy continues, and we have no reason to believe it won't, galaxies will recede from one another faster than light. One by one, they will slip beyond the cosmic horizon. From our vantage point, stars will vanish, galaxies will fade, the sky will go dark, not because the stars died, but because their light can no longer reach us. We will become cosmically isolated, a lonely island of light surrounded by darkness, not because we are alone, but because the rest of the universe is fleeing faster than we can ever catch it. This is the long view, and in that distant future, only the Milky Way Andromeda merger Milkomeda will remain visible. All else will be memory and mystery. We call this scenario the heat death, not because the universe will burn, but because it will cool, evenly, eternally. No more stars, no more gravity wells, just thin gas, black holes, and the slow fade of entropy. It's not dramatic, it's not explosive, it's quiet, en éternelle expansion, a silent unraveling, a universe growing into emptiness. But maybe this is not a cause for despair. Maybe it's a call to humility, because for all our telescopes, all our equations, all our maps and models, we've only just touched the surface. The cosmos is not a solved puzzle. It's a riddle with moving pieces, a sea of light balanced on a sea of shadow. And in that shadow, in that 95% of reality, lies a deeper question. What else is hiding there? What happens when the universe runs out of future? Not metaphorically, literally. What happens when every galaxy has faded, every star has burned out, every atom decayed, and every black hole dissolved into radiation? What happens when there are no more clocks because time itself has no more change to measure? This is not science fiction. This is the long, cold breath of cosmology. This is where the story leads. And yet, Even here, at the edge of cosmic death, something strange remains alive. Let's rewind the clock not to the past, but to the far future. Trillions of years from now, the last red dwarf stars will flicker out. They burn slow, steady, and dim the smallest candles of the cosmos. But even they will die. No more starlight, no more fusion, just drifting remnant, white dwarfs, neutron stars, black holes. Matter collapses, energy spreads thin. The universe becomes a desert, cold, dark, and quiet. A place of stillness, but not quite motionless, because gravity doesn't stop. Black holes, the last mighty engines, will linger for eons, but even they are not eternal. Thanks to Stephen Hawking, we know that black holes radiate slowly, invisibly, through quantum processes at their event horizons. This radiation saps their mass. It's called Hawking radiation. Over unthinkable timeframes longer than all of cosmic history so far, black holes will evaporate. One by one, they'll disappear into nothingness. No mass, no light, no shape, just silence. This is the heat death of the universe. Not a fire, but a freeze, a thermodynamic end, where energy is so evenly distributed that nothing can happen. No gradients, no structure, no entropy left to increase. And without change, there is no time. This is the death not just of stars, but of the story. And yet, the story doesn't end here, because even in the deepest quiet, the universe may still remember how to dream. Physicists don't all agree on how the cosmos will end. Some models suggest the heat death is final. Others hint at deeper mysteries. One idea is the Big Rip. If dark energy grows stronger, space could stretch so violently that galaxies, stars, planets, even atoms are torn apart. The very fabric of reality could unravel. Another is quantum rebirth, that fluctuations in the empty vacuum could spark a new Big Bang, a new universe, blooming like a fire from nothing. Some physicists believe this has already happened not once, but countless times. That our universe is just one bubble in a vast multiverse, where universes are constantly expanding, colliding, dying, and being born. We call it eternal inflation. A cosmos not with one beginning or one end, but many. An infinite tapestry of stories, each with its own physics, its own laws, its own destiny. And then there's the strangest possibility of all, that the universe doesn't end in heat or cold or silence, but in consciousness, that perhaps awareness itself plays a role in the story's finale, just as it did at the quantum level in the beginning, that the observer shapes not only what is seen, but what becomes. It's speculative, yes, but so was every major leap in science, until it wasn't. So where does this leave us? On a planet spinning through the arms of a galaxy, falling towards something ancient and vast, shaped by invisible forces, surrounded by light we cannot see, and driven by time that may one day forget how to move. And yet, here we are, asking question. That alone is a miracle, because for a brief moment, a flash between one eternity and the next, the universe knows itself. Through us, through minds that wonder, through eyes that scan the sky, through hearts that ache to understand what it all means. So maybe this is not the end. Maybe it's an invitation to live not just in awe, but in participation. To be a part of this mystery, not above it, not below it, but within it. We are made of stardust, yes, but we are also made of curiosity, of longing, of story, and that story isn't over. Not while we're still here, not while we're still listening, not while we still whisper into the dark. What else is out there? What else are we? Close your eyes, picture the stars, the galaxies, the filaments of cosmic web, then let them all fade away until there is only one light left. Yours, still burning, still wondering, still watching the universe unfold.